If a dart is thrown at random and lands within the square below, what is the probability that it lands in the orange shaded circle or shaded portion? So here's what I think of in terms of probability. Probability is what you want out of the total. So I'm a fan of doing what we call a picture equation for this, kind of like when we had composite solids or shapes, we drew a picture. So one of the things that I'm going to do is introduce just quick this notation for probability. So this P stands for probability, and the word inside is the event. So what's the probability that I hit orange? Well, probability is what you want. And what I want is I want the orange shaded region. So what I need to do is I actually need to take the area of the square as if it was completely shaded in, and then we're going to subtract the area of the circle, right? And that, if I take this area of the orange square and I cut out the circle, what's left over is this part right here in orange. So that's how we find out what we want. And then the total is the area of the entire dartboard. In this case, it would be the 12 by 12. So I basically need to find those items. And what you could do, some people like to just kind of work vertically. Well, what is the area of the orange square? Well, if it's a square, it's the 12 by 12 or 12 squared. And that's the same as the bottom here. So I know that the bottom of my answer has to be 144 for now. It could be reduced. All right, and then we've got 144 minus the area of the circle. So now I just have to deal with the circle piece here. And if the entire length across is 12, that's the diameter, which means the radius would be 6. So pi times radius squared, I might call that 36 pi. Right? 6 squared is 36. So if I do 144 minus 36 pi, that will give me the area of the orange piece right up top. Now, there's a couple of ways to do this. With probability, I'm not super concerned about reducing the fractions, right? Because especially if our pi is in the answer, I don't really care about the exact answer here because that doesn't tell me a lot about probability. So what I'm going to do is I'm going to use the pi button. And I'm going to figure out what 144 minus 36 pi is. And we get 30.90266,447. And then I'm going to take that answer, I'm going to divide it by 44. And we get 0.2146. And we always want to round to 3 decimals. This doesn't really turn back into a fraction nicely. So you could leave it as 30.90266,447 over 144. But when we express probability, we express it mostly as a decimal. Or we can move the decimal spot 2 spots over. And a lot of people understand probability better as a percent. So you have a 21.460. I should round that to 3 decimal spots just to be more accurate. But if this dart was thrown at random and it had to hit somewhere in this orange, you get a 21.460% chance of that happening. So you can hopefully see why this comes into play with what we just learned. Area, right? What did we take? We took the area that we want, which was the orange, and we had to find that by doing the square minus the circle, over the total, which was the entire outside region. Okay. So we're not going to do a ton of stuff on this because really the only notes you need today are right here. If you didn't write this down, please do so. And if you need a little more explanation on how and why we think of probability, think of flipping a coin. Right? You don't have to write this. This is just kind of like a little side work here. If I said you flip a coin once, and what's the probability of you getting a head, right? Well, what you want is a head. There's one head out of two total options, right? Or what's the probability that you roll a dice and you roll a number 4? Well, there's 1 4 out of 6 total possibilities. So what you want out of the total. If we mix area problems in there, there's nothing different, right? It's the area of what you want, which is usually the most amount of work, over the area of the total. Okay, so any questions on this specific problem or the concept of probability right now? So our goal today is to explore geometric probability. Well, what makes it geometric? The only difference between geometric probability and other probability is it involves the use of either length, the length of a segment, or the area of a shape. And then our goal today is to use area to determine probability. And a lot of times we make reference to a dartboard problem or like a carnival game where you have to hit an object that takes up a certain amount of space. Officially, this is section 11.7 in your textbook. You can refer back to that if you have any questions. And we're just going to look at a couple examples, maybe a quick definition officially of what probability is. So it's up to you if you want to write this part right here, but we're going to define probability as the likelihood that an event will occur. Now, do keep in mind that we can express a probability as a fraction, decimal, or percent, and we do expect that you're fairly confident in those answers in terms of how you represent them. So if you had a 1/4 chance of something happening, we know that that's 0.25, and we move the decimal spot 2 spots. So we would know that that's a 25% chance of happening. I would like you to practice that and just write all 3 of them. Sometimes your fraction doesn't reduce nicely, so it's not really convenient to have a fraction. In that case, the decimal and the percent would be better. So what is geometric probability? It's basically, since we're talking about geometric, it's going to be the probability of an event. So like we had the orange dartboard in the warm-up. So I said the probability of the orange was the measure of what you wanted over the total area, or if we're referring to length, it would be total length. Just depends on the context of the problem. But that's how we want you to think of probability. It's always what you want over the total. So we're going to look at an example down here that I actually don't want you to write. I just want you to answer this, see what you get. This is meant to be a fairly quick problem. So let's say that find the probability of a segment. In exercises 3 through 6, we're going to do number 5 and 6 here. It says find the probability that point K, a randomly selected item on the line from A to E, is on the given segment. Express your answer as a fraction, decimal, and percent. So think of this. Let's do number 5 first. So you have a segment that goes all the way from A to E. And you're asked, what is the probability that if I randomly pick a point, it lies between D and E? So go ahead and see if you can express your answer as a fraction, decimal, and percent for number 5. And then if you get that done, go ahead and do number 6. Okay? And you don't have to chat this one, just give it a shot. Okay, let's look at number 5. So what we want is the length of DE. That's what's highlighted in green. And the total is the length from A to E. So the way I would write this is probability of event DE is equal to what we want, which maybe I'll just write this as an expression first, because that's technically how we're thinking of this. What we want over the total. And then we just have to count or creatively find this. You can notice every length is 3, but a quick way of finding the length of DE is take the larger point minus the smaller point. 12 minus 3 tells me there's a total length of 9. And then to find the length of A to E, that's taking the large one minus the small one. So 12 minus negative 12 is 24. And then we have to reduce. And when they say express your answer as a fraction, it's always a reduced fraction. So you want to divide by 3. So we get 3/8. 3/8 is 0.375. And then we always move the decimal spots 2 spot to the right. Some people like to times by 100, and that will do the same thing. But number 5, the probability of event DE is 3/8, 0.375, or 37.5%. So that's the likelihood that a random point would drop on this green line. So what about number 6, right? What we want is what's the probability that a random point K would land on this line A to E? Well, what I want is I want the length of A to E over the total. And in this case, you don't even need a number line, right? You don't even need a value. If I have the same thing over the same thing, that's 1 over 1 or 1, right? So my decimal answer would be 1.0. If I move that 2 decimal spots to the right, that means there's a 100% chance of that happening, right? Because it is the entire line, so K has to lie somewhere on there. So that's how you would deal with probability involving length, right? The next example we got today is just another area one. It's very similar to the warm-up. So I'm going to have you guys give this one a shot. Let's pretend that our dartboard now is this shape overall, and you have the dimensions. What is the probability that it lands in the blue shaded region? So I'll give you a couple minutes. So let's go over this. A dartboard is thrown at the board below. What is the probability it lands in the blue shaded region? Now there's 2 pieces, but what we want to do, because we don't really have enough information, I don't know the length of this triangle or this triangle, and I can't really guess, right? Now there might be more creative ways to do this problem, but the way that I view it is to find the blue shaded area, we're taking the area of the trapezoid and we're just subtracting the area of the rectangle from it. So let's deal with that part first. If I find the area of the trapezoid, we got to think, what is the area formula for a trapezoid? That was 1/2 base 1 plus base 2 times the height. So my bases are the sides that are parallel. How do I know they're parallel? Because the 90-degree angles tell me that both of these sides are parallel, because consecutive interior angles are supplementary. So there's a reason why they didn't have parallel markings. And then it doesn't matter which one you call base 1 or base 2, and the height is indicated by the distance between the bases. So that will be 20 plus 8 times 5. And let's see, 20 plus 8 is 28. 28 cut in half is 14. 14 times 5 is 70. Now notice, that area is the exact same area as the bottom one, so you don't have to do extra work there. You know the bottom is 70. And then all I have to do is subtract the area of this square, or excuse me, rectangle. And the rectangle is a 5 by 8. So 8 times 5 is 40. And that leaves me with 30 over 70. Now, a quick way to reduce this, they're both divisible by 10. So I know that the answer is 3/7. That's my fraction. If I convert that into a decimal, I get 0.42857. And then if I move that to 2 decimal spots to the right, that gives me about a 42.857% chance of hitting that if this was a dartboard. Right? Or another way to think of it is the blue area takes up 42.857% of the overall shape. Okay, now you do have to read carefully because sometimes we could ask you to find the probability of hitting the white spot. Now here's a quick hint. Without doing a lot more work, what's a really quick way to find the probability of hitting that white area? So one thing to think of very quickly is if you already know these answers, is if the blue area takes 3/7 of the space, then the white area has to be the remaining spot of that. Now, some students don't love that because where did this 4/7 came from? Well, think of this. 7 out of 7 minus 3 out of 7. 7 out of 7 represents the whole area. The 3/7 is the area of the blue, or the probability of the blue. So all I did was take 1 minus this answer from the blue. And that's just another way to think of it. If I do 1 minus that answer, that would be 57.4.1. Let's see, 0.571429. Or if I move that over to a decimal, you could even round that up to a 3 right there. But if you have something that's only made up of 2 pieces, white or blue, and you know the probability of 1, then subtracting the answers from the whole will give you the remaining pieces. So that's just another way to think of probability. You weren't asked to find the white shaded area probability. Okay, so what we're going to do here is please listen very carefully. We're going to introduce a project, and tomorrow is Wednesday. You're going to have all day Wednesday to work on this project. You will also have most of Friday to work on it as well. And this is going to take place of a chapter test. So this will be a 50-point project. I'm going to show you that right now. And it's officially due Friday, February 5th. So I'll show you where you can access this, but I want to basically show and teach you what this project is all about. So please pay attention. You will, when you go to Schoology, you will open up a link and you will have this document right here. It has all these slides on it, so you can go through and read them. The gray ones are kind of the instructional slides. The 4 white ones, actually 5 white ones, those are the ones that you fill out, and those are your project. So, Chapter 11 project, your goal is to design a carnival game using geometric probability. For this project, you will use what you have learned about the area of geometric figures and geometric probability to design a carnival game. Be creative with your game theme, description, and design. It is a 50-point summative project. Please follow the instructions carefully. So you're going to choose a style of your carnival game. Is it a bag toss, a shooting range, a dartboard, an archery challenge? Get creative. Then you're going to decide, do you want to create this game digitally using the Google slide? And I will show you an example of a project that I created so you get an idea of what it looks like. Or if you want, you could create this using a paper and ruler and do it by hand and then just take a picture of that and submit it. Now, if you do it by hand, you're just doing a dartboard on a piece of paper. You don't actually have to play this game. So keep that in mind, is we're not actually playing this game, we're just creating the board itself. So what are the requirements? There must be at least 5 different shapes, which we're going to call holes or targets, inside the playing area. you have to choose at least 5 different shapes from the following. So you could have a parallelogram, rectangle, rhombus, square, triangle, trapezoid, kite, circle, a sector, or a composite, which is 2 shapes or more. For example, a triangle on top of a rectangle, or like we had just seen in the warm-up and the last problem, those were a composite. It was a shape within a shape. So you can get creative with that. But what is the goal of this project? The goal of the project is to make the probability of winning your game, hitting your targets, as close to 50% as possible. Now, we do understand that it's a challenge to get exactly 50%. And if you're close, we are going to offer some grace with that. So if you're really close to the 50%, we're going to be more generous than you think. So, if you get let's say that your probability was 10%, that's not close, right? But if you were at 45% or 52, 53, 54%, that's really close to 50%. So, because it's not going to be super easy to get this challenge. All right, so what do we have to do? You'll have to complete a calculations page, which has you find the dimensions, the area, and the geometric probability for each target or shape. And then after you have that, you have to design your game, find the geometric probability of winning, and write a short paragraph, at least 3 sentences, for each of the questions on the conclusion slide down below. And then there is a self-evaluation score. So that's a lot. I think seeing an example let's see, is the 50% the total percentage of hitting the target? It's all the targets put together. Yep. So I'll show you as an example here. Now there's a rubric. If you want to, you can read through this very carefully, but what's the gist of the 50 points? Okay, so you get 10 points for kind of adding a little creative design and style and a theme to it. So I'll show you my example coming up. So that's worth 10 points. And you can see how you would earn those 10 points. And then you've got the number of shapes incorporated. So if you want to get 10 out of 10, you have 5 different shapes or a composite shape. And then you get 20 points for your calculations. And that's kind of the correct dimensions, area, geometric probability. And that's the bulk of it, 20 points there. And then you get 10 points for filling out the conclusion. So when you're done with your project, you're going to go to the self-evaluation and you're just going to type your score in here. What do you think you got out of the 50 points? And if you met all the requirements, there's no shame in saying, I got 50 out of 50. Because if you did exactly what you need to, perfect. But if you know you didn't have all the shapes or you didn't answer the conclusions using 3 full sentences, score yourself accurately enough, and then we'll put our score in here so you can see what you get. All right, now I know there's questions, and what's going to happen is, how do we do this? So I want you to pay attention to this link. I have a video on how to view formatted shapes in Google Slides. So if you click on this, you just click on the video here, and it's a 6-minute video. Unfortunately, sorry, it's me talking. But it goes through how I set up my project, and it shows you how it basically explains a little bit of the project, but it explains how to format the shapes. So I'll show you that a little bit, but it's using some of the tools up here. So I'm hoping that you make reference back to this video as often as you need. Some of you are way better at this than I am. So that video is there just for you to watch. We're going to talk a little bit about it today. And then if you want a partial example, now I didn't do the whole example, and the reason why is I don't want students just to fully model and copy that, right? I want you to be creative. So I did a partial example here, which you will have access to. You can click on this, and then I'll just show you roughly how my example looks. And note, I just said this is partially complete. You would need to do all of it. But what I did was, here was my introduction page. Okay, my title was called Chuck a Chicken. Right, the object of this game is to toss a small roll of chicken at a chicken coop. You have to make it through one of the 5 doors, and you are a winner. And then name, classroom. I kind of added a little jazz to it, so you can read that if you need to. And then here's my game board. right? Now, I only did 4 shapes. I didn't do 5 because I didn't need to go all the way through it. But um, if you throw a rubber chicken and it goes through one of these, notice there's a couple things that you really have to look at. What is the area of the total board, right? Well, look it up here. See how this goes from 0 to 10? Those are in inches, right? So my entire board is 10 inches by, this goes from 0 to 5.5. So it goes, this is a 10 by 5.5. So when I calculate my geometric probability, the total area is 10 times 5.5. Okay, so just keep that in mind. Um, and then how did I create a shape? Let's say I wanted to do another shape here. What I'm going to do, and this is part of what the video explains, is I'm going to go to add a shape, and I want to pick a shape that I didn't show yet. Now, I didn't have a circle on here, so maybe I want to do a circle right here. All right, and then you can color it. And again, the formatting side here, maybe I do red. If I double click on it, I can call that door number 5. But here's the important part. How do I know the size? You have a couple of options. Your best option is right here. Do a right click and go down to Format Options. And the video explains this. So when I go to Format Options, the first item is Size and Rotation. When I click on that, this is the width and the height. Now it's a circle, so the width and the height are the same thing, but that's basically my diameter. Now, is this truly a circle? No, because the width and the height aren't the same. So what if I wanted to make this friendly numbers, right? I want that to be a 2-inch by 2-inch. Now it's a true circle. The height and width are the same, and I know that across this length, that has a diameter of 2. So I could find the radius from that and then calculate the area of this shape. All right. Now, what if I go to this one? Notice how when I click on this shape, I already have format, size, and rotation is up. See, it gives me the width. So even though it's rotated, by the way, you can rotate it here, or you can grab right here and rotate it however, not that one. You can rotate it however you want using this little toggle here, if you can grab it right. Right? But you do want to make sure your entire shape is on the page, so you can just slide that wherever it needs to be. Anyways, you are going to use the width and the height as your dimensions. And that works great for triangles, works great for rectangles, it works great for circles. Sectors are a little hard, so we're going to allow some variances if you use a sector. And trapezoids are tough. So look at this one. I made a trapezoid, and I had the width be 3. So the bottom here, that's 3 inches, and the height is 1.5. But how do I find the width of this base right here, the top base? Here's my advice, is once you have the size that you want, if you take this and slide it up, slide it up top, see how you can get this close? So that's at a 3, 4, 5. I might call this length 1, 2, 2.25. So you do have to estimate when you're dealing with the trapezoid. All right, and that's the only one that I can really think of that might cause a problem. Now, you can kind of clearly see here, just visually, this is not going to take up 50% of my space. So I would have to go back and adjust. And a hint is adjust the ones that are easier to deal with, right? Rectangles, squares, those are easy to deal with, but you don't want them to be overlapping either, okay? And then the last piece is look at door number 3. Door number 3 is a composite. So I'm going to move this up. It's a composite. It's made of a semicircle and a square. So if I click on the square, it's a 1 by 1. I can find the area of that. And then the circle is a 1 by 1, so I know that it's a perfect diameter of 1. So then to find the area, I would take the area of the square plus half of the circle, and that's how I would do a composite. All right, so anyways, that's a small example of what your board could look like. And then I'd have to do the calculations. Now, I didn't do all of them, but this is the calculations page. And look at shape 1. It was a rectangle. Its height was 2, its width was 1.5. So then I calculated the area. Then I did it for the triangle, and then I'd have to do it for the remaining 3 shapes. And then we have to find what's the probability of just one shape compared to the whole board. What's the probability of target 2, 3, 4, and 5, and then what's the total shape area, and what's the total probability. So this is our calculations page. And then the conclusions page has you answer this question and this question. And then you're done. Okay? So you have the ability to view my project that I just showed you right here and the video. Definitely watch this video. And then on the project, when you open it, it's the work that you just saw. So you're just going to change these. You are free. Once you type something in here, delete it. You can delete the entire text box if you don't need it. Okay? So that's the project. Any questions on that right now that you can think of?
What's the like 50% again? Like 50% that it should go in or that it should?
Well, either or. It's officially it should. It depends on what your name is or what your game is. So here, on my title page, I said the object of the game is to toss a small rubber chicken at the chicken coop. If you make it through one of the 5 doors, then you're a winner. So for me, I want to make it where the area of the targets is 50% of the area of the whole slide. So in that case, mine would be making it through the board. So, and again, you get to be creative. If you find another way to explain this or do this, then you can do it however you want, as long as you want that 50% has to be all of these shapes should be added together, should be 50% of the total 10 by 5.5 inch board. Okay, and there might be some questions that you have as you go on. Now, what we want to do is we want to give you some practice at that, and your homework tonight. So your homework tonight is kind of leading you up to be successful on that. So here's what we have for homework. It's 11.7, but it's on a Google slide, and it can be found under today's folder in Schoology. And we want to make sure that you record your answers on the Google slide provided. So let me show you where that is. So if I go to our Schoology page, and it's week 9. Oh, these are unpublished. Weird, that shouldn't happen. I will publish them now. Okay, so if you go under the Tuesday section, here's where you click on the 11.7 homework, and then it might view different for you, but you open up 11.7, and it will give you your own Google slide. Okay, and then the instructions are here. You have to name the shape, record the dimensions, find the target area, or the area of the target, and then find the geometric probability, and remember that the entire game board is 10 by 5.5 inches. So let's look at, you have 4 shapes. Here's the first one. And just a quick refresher, I want to name this shape. So you're literally just going to type in parallelogram, right? There's your first answer. And then your dimensions, you want your base and your height. Well, how do you find that? Do a right click, format options, size and rotation. And the video on the project explains that. But look at, here's the height, or excuse me, width. It's 7.5, so I would type that down here. And you can say base if you want, or you can call it the width. And I would just say, okay, well, that is 9.16. And then the height, which is just called the height, that is 1.3 8. And I should put units there. They're all in inches. Okay? And then you're going to calculate the area. And then your geometric probability, you got to calculate that. And you can give your answer as a decimal, percent. I wouldn't do a fraction because these aren't going to be super friendly. But then you can go from there. Oh, shoot. You know what? I made a small mistake. Notice how everything changed when I clicked on this box. So I want to go back here. So I just saw that. My width and height are not what I have written down. So I got to record this first. So 7.5 and 3.25. Almost screwed that up. 7.5 and 3.25. Okay. And then now you have everything you need. Okay. The only one, I'll show you this one here. Notice how I already have the format options up. I don't have to right click every time. But here it says width. When they refer to width, it's the entire length from one diagonal across, and then the entire height is here. So you actually have both diagonals, but they call it width and height. And then on number 5, this is the one that you're going to be able to find the width of the bottom and the height, but we don't know the width of the top. So you can move this and get it close to a number. So like here, it's close to 3. So I'd count 1, 2, 3, 4, 5 roughly. And that's the only one that you'll have to estimate on. But that's your homework tonight, is to do these 4 shapes, and you're going to type your answers for each spot right there. All right, so you know where that is now. That's under the Tuesday folder. If you want to start on the project is actually right here under the Wednesday folder. So if you get this homework done pretty quickly and you want to start on the project today, go ahead. It's officially due on Friday, and we'll meet in class. And then Friday is basically a work day to get questions answered and everything. You do have to show up for attendance as well on Friday. All right, that's all. Go ahead.
Can we do more than 5 shapes on our project?
You can do more, but you want to make sure your goal is to get close to 50%. So if you're close, like let's say you're at 43% and you're like, I don't want to change what I have already, then just add another target that gets you closer to that 50% range. So you have to do at least 5, but you could do more if you want. In that case, you might have to add more to the project just to make sure all the calculations are there, but the project is set up so you have 5 for sure. So what I'd like you guys to do right now is start on the 11.7 homework, and I'm going to hang out for the next 15 minutes. So if you have questions, I can help answer those questions now. And my thought is if you can do the homework for 11.7, then the project is going to be very similar and you'll be successful on that. Okay. And you know what I might do actually? I'm going to send you guys the link to that video, even though I know that way you don't have to open up your project unless you want to. But I'm going to send you this video link in the chat. So if you want to watch it right now, maybe watch that video and it shows you how to format using Google Slides, because that's really the only thing that I see some students struggling with. But the rest of the time is yours. If you want to stay on Zoom, you can. If you feel like you got everything, do 11.7 homework tonight. And then for sure on Wednesday, you're starting the project, if not earlier. Have a good day. Sure. So there was a question on how to find the dimensions of a shape. I can go over that really quick. That video link that I just sent goes over the same thing, but let's say that I've got, ooh, this is a good one. Let's say that I have this composite shape, so I have to find the dimensions of both pieces. Well, what I would do first is click
What do you call that?
a composite shape. So I'd say it's a parallelogram and a triangle put together. So that would be the name. And then if I do a right click and I go down to Format Options, Size and Rotation, and then here, this gives me the width, which is just one of these. I think it's officially this length right here. And then the height. So this would be 3.1 by 2.59. You could think of that as your base times your height. So 1/2 base times height would give me the area of this shape. And then if I click on the parallelogram, notice the width and the height will change. So now this is a 4 by 3 base times height. And then to find the area of this shape, you would just add the two together. So it's all in that right click, format options, size and rotation.
Okay, thank you.
Wait, what do you mean by dimension?
Dimensions is kind of what we were just talking about here with like the width and the height. So if I was looking at this example, what you would really have to do is you can pull this apart if it makes more sense, because then you can see the two differently, but it's officially a triangle and a parallelogram. So what I would do here is I might say, well, I know that parallelogram has a base, or you can call that width of, now, unfortunately, when I start typing, this width and height changes to the text box, so I got to go back up here. Notice when I click on that, under the format options, the width is 4, so that's down here, and then the height is the distance between the bases, that's 3. So for dimensions, I would say the width was 4 inches and the height was 3 inches. And then I would also have to say the dimensions for the triangle, right? Because the triangle is different. So then when I click on that, the format options tell me the width, and you could think of it as this one is 3.1, and the height is 2.59. And then you would just, you can call it a base, or some students like to keep that width. I think it was 3.1, and then the height is, I forgot what I said, I think it was 2.59. But unfortunately, when I start typing, yeah, it's right here. You got to click on the shape to identify that. Does that help?
Oh yeah, it did. The geometric probability, is it gonna be in percentage or like
You can do
or
you can do a
fraction
fraction, decimal,
or
or
anyone?
percent. I'll tell you, the fractions aren't going to be friendly.
Speaking of Tuka, right?
So yeah, any of them are correct. I would for sure do a decimal and a percent. I don't think I would write the fraction.
Oh, okay,
Yep.
thanks.
Alex, how you doing? You got any questions?